we have spent this course learning how the cloud works and IT Wolf, where it lives, how you access it, who secures what. Today we look at something just as important and far too often ignored until the first shocking invoice arrives: how the cloud charges you money. Cloud economics is not an accounting footnote, it is a core engineering skill. The way you architect a system directly determines what it costs. Which means cost is something you design, not just something that happens to you. Teams that understand this build cheaply and sleep well. Teams that do not get surprise bills that can be genuinely frightening. So today, we will demystify cloud pricing completely. We will see the fundamental shift from buying to renting, exactly what you pay for, the different ways to pay, the one trap that catches almost everyone, and how to keep costs under control. By the end, the cloud bill will stop being a mystery and become a lever you control. Let us talk money. Here is what we will understand today. First, the shift from CapEx to OpEx. Second, the pay-as-you-go model. Third, what you actually pay for. Fourth, the different pricing models. Fifth, the data transfer trap that surprises everyone. And sixth, how to optimize and control your costs. Let us begin. Let us start with the most fundamental change the cloud brings to money, and I do want to. A shift in the very type of cost. The old way was capital expenditure, CapEx. To run software, you bought servers and A212, a large sum of money spent up front before you served a single customer. You purchased hardware you hoped you would need, installed it, and it was yours to own, power, cool, and eventually replace. That is a big, risky, one-time bet on capacity, made in advance. The cloud way is operating expenditure, OpEx. Instead of buying, you rent an A212 valve, paying for computing capacity by the hour, as an ongoing running cost, like a utility bill. There is no giant purchase upfront. You pay a little, continuously, for exactly what you are using right now. It becomes a flexible operating cost, rather than a fixed capital asset. Why does this matter so much? Because it removes the huge upfront barrier and the risky guess. A startup no longer needs a fortune to buy servers before launching. It can start tiny, paying pennies, and grow its spend only as its usage grows. You never have to predict and buy capacity years ahead and A212. You scale your cost with your actual need in real time. That flexibility is one of the deepest advantages of the cloud. So the takeaway, the cloud turns a huge upfront capital purchase, CapEx, into a flexible, pay-as-you-go operating expense, OpEx, and A212, removing the big barrier and the risky guess. So your costs can scale with your real usage. That OpEx shift rests on one simple, powerful principle that runs through all cloud pricing and 80-100-fold: pay-as-you-go. You pay only for the resources you actually consume, measured finely, and A212 by the hour, and for many services by the second or even by the request. There is no flat fee for capacity sitting idle in the way. Owning a server charges you whether you use it or not. If you run a server for 3 hours, you pay for 3 hours. Run it for 3 minutes, you pay for 3 minutes. And the flip side is just as important. Turn something off and you stop paying for it. The meter stops when you do. This is completely unlike owned hardware, which costs you money and 85 to Paul. In electricity, space, and depreciation and 85 to Paul, whether it is busy or gathering dust. In the cloud, an unused resource you have shut down is a resource you are no longer paying for. This single principle reshapes how you think about resources. Now, because idle time is wasted money, you are rewarded for turning things off when they are not needed and 81 pulo. The test environment at night, the batch job after it finishes. And because you pay per use, you can afford to experiment, spin something up, try it, tear it down, and pay only for the brief time it ran. Pay as you go makes resources disposable in the best sense. So the takeaway, cloud pricing is pay as you go, and 8212, you pay only for what you actually consume, down to the hour or second, and the moment you turn a resource off, you stop paying for it, which rewards shutting down idle capacity. Cloud bills can look intimidating with hundreds of line items, but almost all of it reduces to just 3 things. Learn these, and any bill becomes readable. The first is compute and AT12, the processing power you use, essentially the time your servers or functions spend running. This is usually the biggest chunk of most bills. How many machines, how powerful, and for how long. Every hour a server runs is compute you pay for. The second is storage and ATU12, the data you keep. You pay for how much data you store and for how long it sits there. A terabyte of files parked in the cloud costs a steady amount every month, whether or not you ever touch it. Storage is usually cheaper per unit than compute, but it accumulates quietly. The third is data transfer and A212, moving data around, especially out of the cloud. This is the one people forget, and we will give it its own slide because it causes the most surprises. Time running, data kept, and data moving, compute, storage, transfer. Almost every charge you will ever see maps to one of these 3 meters. So when a bill looks scary, sort it into these buckets and it suddenly makes sense. So the takeaway, nearly every cloud bill comes down to 3 meters and 8,200 pol. Compute for the time things run, storage for the data you keep, and data transfer for data moving out, and 8,200 pol. And sorting any bill into these 3 makes it understandable. For compute especially, you are not stuck paying one rate and 8112. There are several ways to buy the same capacity, and choosing well can cut your bill dramatically. On demand is the default, full flexibility. Pay the standard rate for what you use, no commitment. It is perfect for unpredictable or short-lived workloads and 82 but it is the most expensive per hour, so it is the wrong choice for anything running steadily. Reserve capacity is for steady, predictable workloads. You commit to using a resource for 1 to 3 years, and in exchange, you get a large discount and A212, often more than half off. If a server is going to run around the clock anyway, paying on demand for it is simply leaving money on the table. Spot is the bargain bin. You use the provider and EFD9, spare unused capacity at a steep discount and E202. Sometimes a fraction of on-demand and E202 with one catch that it can be reclaimed at short notice. It is ideal for interruptible work like batch processing that can restart. And savings plans let you commit to a certain amount of spend over time for a discount, with more flexibility than reserved. The key skill is matching the model to the workload, steady work on reserved or savings plans, flexible work on on-demand, and interruptible work on spot. So the takeaway, match the pricing model to the workload and OT112, on-demand for flexible or short-lived work, reserved and savings plans for steady predictable workloads, and spot for cheap interruptible jobs, and OT112 because steady work paying on-demand rates is pure waste. Now the single most common billing surprise in the cloud and A212, the one that catches beginners and experienced teams alike. It is worth burning into memory. Here is the asymmetry. Data coming into the cloud is usually free. Providers happily let you upload as much as you like at no charge because they want your data on their platform. Uploading terabytes in costs nothing, which lulls people into thinking data movement is free. But data going out of the cloud is charged, an A212, and this is called egress. Every time your data leaves the cloud to reach your users, another provider, or your own office, you pay per gigabyte. For a service that sends a lot of data to users, and it equals videos, downloads, images, and it equals, these egress fees can quietly become one of the largest items on the entire bill. And they are almost invisible until they add up. The reason this trap is so dangerous is that egress is easy to overlook when you design a system and A200 fall, you focus on compute and storage and forget that shoveling data out has a price. Architectures that move data across regions or out to the internet unnecessarily can rack up enormous transfer costs. Being aware of egress and designing to minimize needless data movement and A200 caching, keeping data close to where it is used, and A200 is a mark of real cloud maturity. So the takeaway, data coming into the cloud is usually free, but data going out and 8112, egress and 8112 is charged per gigabyte. And because it is easy to overlook, it surprises more teams than any other item. So always design with data transfer costs in mind. Before we optimize, a friendly note for learners with one important warning attached: an A202 poll, the free tier. What it gives you is genuinely generous. A free allowance of many services, enough to learn, experiment, and build small prototypes without paying anything. This is how you should explore the cloud and AT12, spin up resources within the free limits, try real services, and learn by doing, all at zero cost. It removes the fear of running up a bill just to practice. But here is the caution, and it is the same lesson from the Getting Started class. The free tier has limits, and it is easy to exceed them without noticing. An 8212. Leave a resource running past its free hours, or store more than the free allowance, and you start being charged. So always set a budget alarm from day one, telling the provider to email you the moment your spending crosses a small threshold. That single safety net turns a potential horror bill into an early warning. The rule is simple: learn for free, but always set a budget alarm from day one. So the takeaway, the free tier lets you learn and prototype at no cost, but it has limits you can exceed unnoticed and A212. So always set a budget alarm from the start, so a forgotten resource can never quietly become a real charge. Not the biggest source of wasted money in the cloud, and it is almost entirely avoidable. And A212, over-provisioning. The common mistake is over-provisioning, giving a workload far more capacity than it actually needs. An 8202, just to be safe. An 8201, a giant server for a small app. 10 machines where 2 would do. Storage sized for 10 times the real data. Because on own hardware, you had to buy for the worst case upfront. People carry that habit into the cloud and 8212 and then pay every hour for capacity that sits mostly idle. This is where a shocking amount of cloud spend simply evaporates. Right sizing is the fix, matching the resources to the actual demand and then leaning on the cloud and TI's elasticity to scale up only when you genuinely need more. Because you can add capacity in seconds, you no longer need to overbuy for the worst case and 8200. You provision for the normal case and let it grow on demand. The same workload, right-sized, can cost a fraction of the over-provisioned version for identical performance. The mindset shift is to stop sizing for fear and start sizing for reality, trusting elasticity to cover the spikes. Measure what you actually use, cut the excess, and scale dynamically. This one discipline and 82-1. Right sizing plus elasticity and 82-1, 201 is usually the largest single lever on a cloud bill. So the takeaway, most cloud waste is over-provisioning, and A212, paying for capacity you never use, and A212, and the fix is right-sizing to real demand and scaling elastically, which can cut the cost of the same workload dramatically for the same performance. Let us gather the practical levers for controlling cloud cost into one place, and A220, the moves that keep a bill lean. First, right size and scale elastically. Match every resource to real demand rather than a fearful guess, and use auto-scaling so capacity follows actual load up and down. This attacks the biggest waste, over-provisioning directly, and it is where you should look first. Second, commit for steady workloads. Anything that runs predictably around the clock should be on reserve capacity or a savings plan, not on demand, and A212 house, capturing those large discounts on the baseline load you know you will always need. Paying on-demand rates for steady work is one of the easiest, biggest savings to claim. And third, turn off what you are not using. Idle resources still bill, so shut down non-production environments overnight, and on weekends, delete storage you no longer need, and clean up forgotten resources. In pay, as you go, switching things off is literally saving money. Right? Size, commit, and switch off an A2x2I. Those three habits, applied continuously, keep cloud costs under control. So the takeaway, optimize costs with three levers, an A212, right size and scale elastically. Commit for steady workloads to capture discounts, and turn off idle resources because they still bill an A2112. Applied continuously, these keep the cloud bill lean. Let us end with the mindset that ties this whole class together and separates cloud amateurs from professionals. In the cloud, how you architect a system directly determines what it costs. The instance sizes you choose, whether you cache to avoid egress, how you scale, which pricing model you pick, whether you turn things off, and A2112, every one of these design decisions shows up on the bill. Architecture and cost are not separate concerns, they are the same concerns seen from two angles. Your design is your bill. So, the professional treats cost as a design dimension, engineered deliberately and AT-wall. Just like performance, security, or reliability, before building, a good cloud engineer asks not only NA221, will this work? NA221, but NA221, what will this cost? And how do I make it cheaper without hurting what matters? NA221, cost awareness is baked into the design from the start, not ported on after a scary invoice. This is why cloud economics is genuinely an engineering skill, not an accounting one. The engineer who understands pricing builds systems that are not just functional, but efficient and AT212. And in a world where the bill scales with every design choice, that efficiency is a real, lasting advantage. Design for cost on purpose, and the cloud rewards you. So the takeaway, in the cloud, your architecture directly sets your bill. So treat cost as a first-class design dimension you engineer deliberately NA21 alongside performance and security NA21 rather than a surprise discovered at month end. Let us gather the whole class in one breath. CapEx to OpEx and A2112. A big upfront purchase becomes a flexible pay-as-you-go running cost. Pay-as-you-go and A2112, you pay only for what you use, and turning it off stops the charge. 3 meters and A21, compute, storage, and data transfer, and A2121 explain almost any bill. Pricing models and A2212, on-demand, reserved, spot, and savings plans match to the workload. The egress trap and A2112, data in is free, data out is charged. And optimize by right-sizing, committing for steady work, and turning off the idle. Next class, N8212, the well-architected framework, designing cloud systems the right way, one idea at a time. That is, cloud economics and A25, and it is a superpower, more than a chore. Pay only for what you use, know your 3 meters, choose the right pricing model, respect the egress trap, and right-size relentlessly. Above all, remember that in the cloud, your architecture is your bill, so design for cost on purpose. Master this, and you will build systems that are not only powerful, but genuinely efficient and A2112, and you will never fear the invoice again. We will see you in the next class.